Hello everyone, welcome to PJ Chemistry channel. Respected all, your views and likes, it is giving to me more like a motivation, and I'm inspiring your likes, and I'm trying to do more and more videos with more confidence. Today we are going to discuss last video continuation. Last video we discussed about melting point, boiling point, latent heat. Okay, this and all based on temperature. So how factors affecting to change state of matter from one state to another state, solid to liquid, liquid to vapors. We are going to continuation. So yesterday's class we discussed effects of previous video, effects of change of temperature. Effects of change of temperature. There are mainly two effects. How many effects? Two effects to change matter from one physical state to another physical state affecting. So in that first one, already we discussed effects of change of temperature. When temperature rising, slowly that solid ice cube converted to liquid. Still, if you are rising, that liquid converted to vapors. Like that, temperature effects on physical state of matter. See here, one more activity with the effects of temperature. Yes, children. If you observe here, there are three cylinders. First cylinder, second cylinder, and third cylinder. If you observe these three cylinders, instead of saying three cylinders, in one cylinder only phase transition by increasing temperature. That is best. Okay, appearing like a three cylinders, but we want to consider it is like a three different temperatures. Same cylinder, three different temperatures. Yeah, if you observe in first case, it is in solid state. The matter which is in solid state. How we are saying solid state means already we know particles are tightly packed. There is a fixed volume and fixed shape, defined volume and defined shape. Okay, that just we are taking it is ice cube at minus 23 degrees Celsius. Okay, at the time, here what I taken the green color which is appearing, it is like a piston which can be moved freely as per the volume occupying the particular matter. Now, what we are doing is slowly we are increasing temperature. Means we are giving heat to the substance. While giving heat to the substance, yesterday we discussed already previous video. Same thing, that solid converting into liquid. Solid occupy less volume. Same solid, once it turns into liquid, it is going to occupy more volume. Because between the particles, attraction decreased. When attraction decreases, it will occupy more volume because space between the particles increase, gap between the particles increase. So, same amount of ice cube when it turns into liquid form, the volume occupying is more. That happens at 0 degree Celsius, that is we called melting point. Melting point. Still we are continuously giving heat. Now if we observe piston, Initially, solid state, they occupied, just you consider like a 1 liter volume. Once it turns into liquid form, same amount of substance, same number of particles, but due to less attraction, more space, they occupy more volume. First case 1 liter, second case it rises to 10 liters consider. Next, still we are continuously giving heat. At the time what happened? Between the particles, attraction becoming negligible. Means there is no attraction. Means particles space increasing a lot. More gap between the particles. That is what we are telling vapors. Means liquid converted to vapors. Liquid converted to vapors. See here, first case solid case only 1 liter volume occupied. Second case when it turns into liquid 10 liters volume occupied. Now if you observe here, consider it 100 liters volume occupied. But amount of substance is same in all the conditions. Okay. Once the attraction decreasing, volume increasing. Based on that increasing volume, the piston is moving. Here piston is just 1 liter volume near to the ice cube. Now when it turns into liquid, the piston move to up. Okay, height of the piston increasing. That means volume increasing. Okay, these are the effects change of temperature. Solid to liquid, liquid to vapors. Next, one more activity also. Solid to liquid, liquid to vapors only not. Sometimes solid directly changes to vapors. Solid directly converted to vapors. That is also, yes. If you observe diagram here, we taken in a tray solid carbon dioxide. Is nothing but dry ice. Dry ice, another name is solid carbon dioxide. When we give heat to the solid carbon dioxide, here arrangement if you observe, to measure, to observe, inverted funnel, inverted funnel on the tray and started to give heat. This is funnel. And started to give heat. When we started to give heat, what happened means this solid directly converting into vapors. Directly converting into vapors. But if you already funnel means both sides open end. So if you leave both sides open end, one side okay we inverted on tray. Another side open end like that only, other means that gas will escape, we cannot able to see. So here we covered that another end with a cotton plug. Cotton plug means it is having porous holes that will minimize the pressure, which will happen, happens collisions in the funnel. Because of collisions, what happens means pressure will increase. There is chances to blast. So to minimize the pressure, we are using cotton plug. Okay, and also it will help to avoid escaping the gas whichever converted to gases form. Okay, now without changing into liquid, directly converted to gas, the process we are calling sublimation. The process of conversion of solid directly into gases, that is we call sublimation. The process we call sublimation. Because we discussed melting, boiling, solid to liquid, liquid to vapors. One more, solid directly changes to gas without changing into liquid form. That is we call sublimation. What are the examples for sublimation? Ammonium chloride, solid carbon dioxide, nothing but dry ice, camphor, incense sticks. Next, if any naphthalene balls, generally we use to observe naphthalene balls. We keep it in cupboards to avoid the insects in cupboards because of that naphthalene ball smell, insects whatever are there, it won't reach the particular area. Okay, so naphthalene balls also having sublimation nature, and nowadays many odonil like that freshness we are using that is also having sublimation property. Okay, anthracene, one of the chemical that is also having sublimation property. This all names already I given in the uh, previous video. Solid state. Then if you observe, you will get to know. Yes, these are the effects change of temperature. Next, one more effects. What are the effects of change of pressure? It's a reverse. Okay, pressure effects. How states of matter convert. Okay, effects of change of pressure. 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 Same way here. Same these diagrams only reverse if you take. Okay. Here we are not going to raise the temperature at room temperature. Okay. I am taking cylinder. It's reverse. Means this third diagram will be as a first diagram. In first case, they occupied more volume. Piston, which can be moved freely as per the occupying volume. Now, initially, molecules occupied more volume. That means that is in vapor state or gaseous state. Now, what we are doing means we are cooling it. Here, 100 liters volume occupied you consider. When we cool it, our pressure is nothing but force applied on unit area of liquid. Means we are going to apply pressure, you consider either cool or apply pressure. At that time what happens? The molecules becomes closer together. Okay, at that time same container, when we apply pressure force on it, the molecules comes to close each other and it occupy less volume. It occupy less volume. Means the piston move down. Piston move down. Still we are cooling or still we are applying pressure. Okay, either cool or directly apply pressure. So at the time what happens means still the molecules comes to close each other and appear like a solid state. Appear like a solid state. They occupy less volume. They occupy less volume. This activity we done at room temperature, consider it. Okay, room temperature means 23 degrees Celsius. Okay, at that condition we applied pressure. Okay, so force applied on unit area of particular substance, at the time it changes to a liquid. When we still applied pressure on the force applied on that, it turns to solid. It acquired less volume. These are the effects of change of pressure. Effects of change of pressure. Okay, temperature opposite pressure means when we apply temperature, pressure should be low. Okay, the conditions where it changes occurs means temperature rising at high temperature, low pressure, solid converted to liquid, liquid converted to vapors. It's reverse. When we are making a reverse process, conditions also reverse. Means at high pressure, low temperature, vapors converted to liquid, liquid converted to solid. Like this. Understood children? Thank you.